So shall we start in for the lab? uh, I'll share my screen. Okay, can you see the questions? Do tell me if you can't see my screen. Right. So yeah, this time we are going to have a look at stack for lab 5. Right. So same thing. Before we uh, before we go to the questions, we'd like to revise a little bit on the previous that we have learned, right? So last time we have already learned that linked list is something like this, right? So linking the variables. So they are simply variables where we call as NODE. So this is linked list. We are linking the variables that scatter around our memory, right? Then with this linked list, we are able to do many things. Basically, we can remove whatever things we want to remove. Yeah, in the middle also can. We want to see the elements in whatever index also can. Yeah, this is the capability provided by linked list, right? And but what is about stack, right? This time we are learning about stack. So actually, stack can be implemented in either way. You can implement in array, it's fine. You can implement in as a linked list, is also fine. I find it more easier to implement in a linked list, right? So stack, let's say if my stack is implemented same as linked list, so what can a stack do? Right. So linked list we can remove or find anything that at any positions, but this is not necessarily needed in some of the use cases, right? So for stack, as I've previously mentioned, it is something like a potato chips that you can put things inside. Then when you want to withdraw it, the latest chips will be removed first, right? This one will be removed, then this one will be removed, then this will be removed. Then you will have no way to look at what is in the items that's not the latest one. Yeah. So you can look at what is this chip, but you cannot look at what is this. Yeah, you cannot look at what it is. So this is a limited version of linked list. Right? If I implement in the linked list way. But why do we need that? Because we don't need to have the functionalities provided by linked list. So let's say if you are having a water bottle, it makes sense to be only able to drink from the outside, right? Yeah, you wouldn't want a water bottle to have uh, another place that you can open from the bottom because you don't need that, right? So this is the same as our data structure. Yeah. So there are some use cases, there are some conditions that we don't want the users to mess up with our system, or we don't want anyone to have access to something that they are not supposed to have. Then we will limit the access. So let's say if we have already implemented a complete linked list, then we want to implement a stack. We just simply remove the methods that are not relevant to stack. For example, for stack, you can only push and pop, right? You can only push the things down, pop, then pick the things at the top. Then you remove the methods for remove first or pick first, something like that. Yeah, you can remove those functionalities that is for queue, for example, right? So this is a rough concept of why do we need a stack? Yeah, to fulfill some requirements that don't require us to give full access to our data, right? We can protect our data by doing this. This is one of the reasons. There are many reasons you can say justification is on your own. Right, so now question one. Question one, yeah, it's the same thing that initially we put a number of candy inside the container one by one. We put it inside blue, yellow, etc. Then uh, Ali will take all the candies one by one and eat the blue one. Then after he add all the blue candies, he put all the other candies back into the container. Then he want to see the container like this, right? So actually, stack is very compatible with recursion, which you can see here. Right, this is for question one. First, I have a class candy. Right, so this candy class only have a string which indicates the colors. So there's nothing else special here. Then I have a toString method to return the candy's color because I want to know, right? Then we have a stack that add all the candies, according to the sequence they want. Then print the candy first, then tag and eat the blue one and print out the result as you can see here. Wow, okay, something like this. So I take the blue, then move it back into the stack. So what is happening down here is this recursive method. Right? Recursion again, we have to have a stopping condition. If the container is empty, no more candy inside already, then we will return the function. Else, we will pop one candy first, then do nothing first to the candy. Yeah, you keep it for yourself. Then you try to attempt take other candies first. Okay, you keep the first one, then you keep the second one, keep the third one, keep the fourth one. Then after the container is empty already, what happened? Oh, total there's a student who can't enter the meeting. Right. Okay. Now we pop everything. Okay. Then when it is empty, you check the latest one first. Then if it is blue, then you discard it. When it's not blue, you push back into the container. So uh so at first the candy will be, for example, 1, 2, 3, 4, 5. Then you pop the first one, the second one, third one, fourth one, and the fifth one. And now you have a empty stack. Right? So let's say this one is 5. This one is 4, 5, 3, 4, 5. Okay, something like this. So initially you have 1, 2, 3, 4, 5, right? Then these things you don't check first, okay? You pop until the end. Then after this empty, then only you check, oh, is this blue? Okay, if not, then I will push back into our stack, which is currently empty. So this one, or is it? If it is not, then push back, then push back, push back, push back. At the end, you will get the results that follows the sequence that they want. So this is very similar to our previous questions related to recursion. So yeah, when you are using the stack, probably you can think of trying to make it compatible with your recursive method. Yeah. So that's it for question one. Then I'll pass to Wai Xiong, is it, for the second question? Right. Stop presenting.
Okay, for question two is require us to write a prefix calculator that can compute integer operation, like you enter the operator such as add, submission, multiply, division, and modulus. Okay, I didn't. I forgot modulus. Okay, so then for the bracket, you were using open bracket and close bracket to represent the operator. So okay, okay, let's say for the 3 plus 4, right? This is what you call it in fix, right? So in postfix, we are writing as 3, 4, and then plus. So this plus is mean you doing the operation by taking the two value before it. So let's say for this one is plus, right? So you will take the two value before, which is 3 and 4, and then you plus them together. So this is how our calculators work. But here they already give you the somehow the pseudo code, the workflow, how you convert the infix to postfix, and you are doing the postfix calculation. Here I didn't use my own stack. I used the stack from the Java library. Probably you need to do the do a stack by your own, or you can use the stack that you uh been been programmed or been written at the question one, and continue you can use it in the question two. Okay, for the progress, right? For the okay, first we read the input. We read the input from a user with the proper format, with the operator. We use the proper format such as add, sub, mount, div, and mode. Okay, after we read the input, right, we convert the input to the proper prefix, proper infix string. So for the input to convert into infix string, we will just use the string tokenizer. You can either use string tokenizer or using string dot split to split out the string with the space. So you will get a list of string. In this case, I'm using string tokenizer, so I read the string one by one between the space. And then I check for the input. If it is the operator, and then I insert the proper it is an operator, I insert a proper operator character to it. Like for the add, I put add and sub, multiply, divide. And then probably we need the mode. I forgot to put the mode just now. So this is the step that we convert the input to infix. So you will get a string of the formula. So for example, when our input is, in this case, you will get a 3 plus 4 multiplied by 5. and then we need to convert it into the postfix to do the calculation for the value. Okay, so for the postfix, we need to, the most important thing is we need to know the priority between the operator. So normally, as we know that for the operator, the priority, the multiply and the divide, and also modulus will be coming, will be have higher priority compared to plus and minus. So that's mean when you're doing the operation, you should solve just multiply, divide, and modulus instead of plus and minus. If you found like multiply or divide together, so they are equally have equal priority. So it means you solving them by first come first serve basics. Here I'm using integer to represent the priority of the operator. So after I get a priority, then I just compare them with the highest number is mean they have the higher priority. Okay, now we've going through for this one in fixed to postfix conversion. But we read the string from it. Okay, this time I'm using string dot split. So I split out with space, and then I get the string, a list of string. And then I check if it is operand, so it means it is a number. So I will just add to the output. So it is a open bracket. So if it's a open bracket, so I will push it into our stack, and it is a close bracket. So we'll pop everything from our stack until we match the open bracket. And then if it is not this three condition, which is it is not a number, it's not a open bracket and is close bracket, so we can consider it is a operator. So if the string is operator, so we will check whether the stack is the size of a stack. If a stack is having operator inside, and then we need to check the priority of a stack. So if let's say the priority of the operator that we read is lower than the stack of the peak of the stack. So that means we will output the operator into our output. So let's say if this one is a plus and this one is a multiply, so we will output the plus into our output. If this one is equal priority, So based on first come first serve basics, we will output the first operator which is coming, which is the this which is operator that inside the stack. So we will pop up the stack also and add it into output. And this operation will be stopped by checking not only the priority and the size, and also we will check the peak. If the peak is equal to the open bracket, we will stop the while loop, since the operator that inside the bracket, right, it should not affect any value outside the bracket. Okay, if you already check the priority and everything, and then we will push the current operator inside the stack also until we reach the end, and then we pop everything that is still outside the stack. So it's based on this algorithm, right? So push first we will output 3, and then we will put plus inside a stack, and then we put a 4, and then we found the multiply, right? This multiply have higher priority than plus, so we will put multiply inside a stack, and then we put 5. Okay, after there's no any input, so we will pop everything that's still inside a stack, which is multiply and plus. Here everyone is okay, right? Okay, if no question, then I will continue. So after we get a postfix, we will do the calculation for the value. So based on here the explanation how the postfix iteration will work is, basically you will push any number or every operand that we found, push inside the stack. So in this case, let's say this is your postfix. You push 3, 4, and 5. Okay. I think will be a bit blur. Let me repeat this. So if we found a number, we'll push it into a stack. If we found an operator, we will do an operation by the two number from the stack. If we pop twice, and then we do an operation, and then we push the answer inside back the stack. Okay, so in this case, we read the first item, which is 3, is a number, so we push it inside a stack. And next one is a 4, so it's 5. Next one is multiply. This multiply is an operator, so we will pop up these two number, and then you do operation, which is multiply. We multiply 4 and 5, we'll get 20. And then we push back the result inside a stack with 20. And then we read the next string, which is plus. So we push back. Hey, so we pop up two number. Then after you do a multiplication, and then we push back a number inside. So after this all number have been finished read, you need to check your stack, the size should be equal to 1. So the value that you pop up will be the answer for the equation, which is 23. So you will just convert the algorithm given into a Java code. So here you can either using string tokenizer or using string.split. In this for now I'm using tokenizer. So I check for every value it is operand, I will just push. Else if it's else is operator, so I will do an operation of with an integer, and the operation string check what is the operation, if add anyway, plus, minus, multiply, division, and modulus. Before you were doing the operation, right? So you need to check and ensure the stack, the size is greater or equal to 2. So it is if the size is smaller than 2, so that means you are not possible to get two value from a stack. So you can be say this equation or this postfix have the maybe have bug or error, so it's an invalid postfix calculation. So after we finish reading all the string input, so we will check whether the stack, the size is equal to 1. It is not equal to 1, so we can also confirm that this postfix iteration they have some errors, since you cannot count because the exact postfix calculation you will get exactly one value inside a stack only, which is the value will be the answer for the postfix, and then we will just return the answer. I return it by string, but probably if you want to return it as a integer can also. Okay, so this is the main part for the question 2. So any question regarding for the question 2? Okay, so here's an example where I doing an input. I convert input into the proper infix equation where bracket inside 7 plus 8 then I times 9. So in here, since we have bracket, right? Since we have bracket, so we will do the operation inside the bracket first. Okay, so here's an example that before that I say for when you are convert the infix into a prefix, right? So you will check the stack. If until the open bracket, you will just stop this operation and you push the operator. So this is to prevent this one is to prevent that the any operation inside the bracket mess up with the outside. So in this case, right, 7 and this plus operation, it should not mess with the 5 and 9. So we will check whether the inside the operator stack, if you found this one, you will stop the while loop and you push the operator inside. Okay, if you don't have any questions, so I would like Sia to proceed for the question 3.
Okay, I will proceed to question three. Uh, oh, Wai Xiong, there is a question for you.
Yes, actually, I'm taking postfix as string. Uh, yeah, this is just the naming error. But inside the main method, I do passing the postfix inside to the method.
Okay, so I will continue to the question three. Okay, so for question three, you need to write a program about the encrypt problem. the pseudo code of a program. So you need to code out the logic of a program based on this. Okay. So I will explain a little bit about the logic. So for this pseudocode actually is checking line by line. Yeah. The concept of this problem is diagonal, diagonal, and then also the vertically. So what is mean by attack horizontal is there is two queen in the same row. If let's say the is like this, it will become attack. The queen attack each other. And then for attack horizontally is in the same the two queen there are two queen in the same column. So these two queen is attacking each other, and this is not allowed in this program. And then for the last one is diagonally. For diagonal, you need to be when you are writing program, you need to be very careful because for diagonal, you have two diagonal. First is diagonal from the left, so it's either here or here, and then these three queen actually is attacking each other diagonally. Oh, these two is attack each other in vertical, and then you need to check about the yeah. So this queen is attacked by two queen, which is the upper one and then the lower one. This attacked by diagonally. Okay. So from this question, from the pseudocode given is actually only using the column. So at first, it will start with the queen at here, and then after actually it will check whether this one is valid or not. There are no other queen that attack this queen. And then if it is valid, then it will put the queen at here. Uh, this is the position of the column which is one into the stack, and then it will jump to the next line, which is this line. It did not continue this line already because there is already one queen occupied at here. So and then for the second one, second row, it will start from zero, the the first column again. So it will check whether this queen had attacked the previous queen. So this one will not be put, and then it will jump to the next position. And then it will try to check. Okay, so this for this queen is still attacking the first queen, so it will be removed. and then jump to the third position. Okay. So for third position is no more attacking. So this position, which the position 3, the number 3 will be put inside the stack. And then it will jump to the third line, the third row. From the third row, it will set the current position to 0, which it will uh, start from the first column again. It will check the queen one by one. So for this queen is not is not valid. And then for this 3 queen is for this queen, actually it will check 2 times. The first time it will check with this queen, and then this queen actually this queen is the new queen is not attack this one, the second row, the queen at the second row. So it will now it will compare to the queen to the first row, which this one, and it found that they are attacking each other, so it will not put, it will remain as the asterisk. Okay, so after these 4 have been checked, so it will enter this one, the second if condition, which if there is no valid position. So we know that here this line, the third row is not, the queen cannot be put anywhere. So we need to jump back to the last row. We need to we can putting more queen inside the board. So for this one, we remove this queen, which we pop up the position, this position, which position 3 that we insert previously inside the stack, and then now we try again with the next position, which is the column 4, this column. So for this column, we will check whether there is valid or not. And then after that, third row, the valid is this one. And then for fourth row, again, it cannot put any queen because it will attack the previous queen. So this one will be removed. And then these 2 will be checked and still attack the previous queen. So this until here, actually it means that is end already. Okay. So so for this row, actually is not putting any queen. So if there is not, it still enter this condition, which is there is no valid position. So it will jump back. Since the stack is not empty, it still have one more queen inside, which is the first queen. So since there is not valid condition, it will remove this queen, and then now it will go with the second column in the first row. So this queen will be putting it here. And then so this it will continue the logic until it reach the last column, which the stack will have size n, which the size of the board, which 4 times 4. Then it will display the solution by popping the stack. Please do note that since it's popping the display the solution by popping the stack, so actually it will be the board will be is upside down. So the last row will become the first row will become the last row, and the last row will become the first row when you printing it out. And then after you printing out, actually it means that all the print have been clear because all the all position is being cleared up, being popped up. The one which if you print, you will uh, get this board, and then you will print the result again is upside down, and then finally, if you reach the fourth column of the first row, this one is the last one, and then if mine cannot, you will jump. So this is the last second step of the step, and then until here, actually, it find that it cannot put any screen inside the third row. It will remove this screen, and then this since here no more put in the second row, the first screen will be removed as well. Okay, so for now this first row also it cannot put any screen because it reached the end already, and then the stack will be empty and it will exit the while loop. It will stop the searching, and then you need to print out the solution, which 2 based on the pattern just now. Okay. So first of all, I'm creating my own stack class, which implement using the array list. And then I will implement my logic in the main method. As the static variable, so that I can because I have two method. The first one is the main logic with the anchoring problem. It will solving the problem at here. And then for this one, the is valid position, it will check is the for the checking of the whether the queen attack each other. So for this method, it will need to access the stack as well. So I'm putting it as the static variable. Okay, I will explain the logic. Okay, so first, we will need to create the empty stack. In the first, and then we start the program. So in this program, actually, I'm able to set the size of a board, which here I set it as a 4. Later I will demonstrate about for other size as well. Okay, so first we will initialize a variable with the number of solution, which we will print at the end of this program, and then we will set the current Actually, if you want to set to 0, is okay. But for thing, you need to remove the the equal, because so that it is same as the from 0 to the n size minus 1. I am using from 1 to the size. Okay, then we will enter the while loop. So in this while loop, we'll use the condition which, if true, we will keep running. The only end condition is the if stack is empty, then we will break this while loop. Okay. So we will initialize the place to false, so that we know that have we put the queen yet. If we haven't put the queen, we will need to enter the second condition, which is the to back. And here we will need to backtracking or to end the program. Okay, then we will iterate from current position to the size. You can notice that for this follow, I did not put the first condition, which is the initialization, because I already initialized upside here. And then I will check whether the position is valid or not. If it's valid, we will push the position inside the stack, which the stack is a stack integer stack. Set the place equal to true, so that we tell a program that this line already have a queen, so you don't we will need to continue to. We should not jump to this condition, and then we will need continue the next line to find the. We start from the first column again, and then we break this for loop. Okay, so if it's not placed, if the stack is empty, it will break. Because if you put the if you stack, which is the last one. So let's say it's like 1 and 3. Remove, and then you will increment it to 4. So that it can start another search. And then if the stack already 4 for this this board, it will be 4. So if the stack is equal to 4, so already find a solution, then we can print this out. We will pop every element inside the stack, and then we will print the board out. Same as this one, the last element. So they, let's say from just now so from this one, the first element we remove is the row, and then the third row, second row, and then the first row. So if you're not searching from the second column again, now instead you should search from the third column. So you need to save this number and then update the current position, the variable, so that this for loop will start searching from the third one. It will not keep finding the same pattern. Print out the number of solution. Okay. So for this is valid position, we will use a temporary stack here. Because we need to remove all element from the stack to check whether the queen has attacked any of the previous queen inside the stack. So if we just pop it out and then we did not save it to any, it will be lost. Okay. So I will pop it out and then I check whether this one is vertically attack each other, whether this new position it diagonally, which I will show it later. If it is, we will push back the previous queen inside the stack. But the new queen, we will not push it in. If it's not, we will continue here, and then we will push the previous queen inside the temporary stack, which we will be pushing it later, pushing it back to the stack, so that we still can reference it in the stack. And then for this one, the row difference is the current. Okay, so let's say the queen is in this position. This fourth position is attack any of the previous queen. So I will use the row difference, where we know that the element in the stack is arranged from the back. For third row, the element before it is the second row. So this we remove it, pop from stack. We know there is actually only one row difference from this. So that from this one, we will be able to check it whether it was, let's say here, the second. So because we only keep track of the S position, if we did not have the whether is diagonally attack each other or not. So I will use this row difference to add as the Y, the difference of Y between these two rows. So if this one, since this one is the previous queen with the new position, the currently checking the queen is only one row apart. So it means that their position should not be one row apart also. And one column apart also. So if this one is 1, this one is 2, then it will be diagonally attack each other. So you cannot put it inside the stack. You need to check again. And then these two, but we need to notice that if you use the row difference, we only is if you use the directly use the you use the second x to minus the first x, it may not get the result because you need to because there is two way is the position maybe is smaller than the previous screen or is bigger than. So we will use the max dot absolute to get the value without the negative and positive. So it will give you only the positive result. And then you check whether the row difference is equal or not. So if it's equal, then it will enter. If this question is true, then the value is previous position queen, and then it will break the searching because this one is not valid. Okay, so let's run the program. Okay, and then when we change it to 5, it's still able to search and then give you a result with 5 solution. If 3, it will not have any solution, so it did not print anything. 2 also same. And then 1, it will have one answer, which is the only queen inside the box. Okay, that is all for question 3. Is there anything you're not understanding? Okay. Okay, if there is no question, I will continue to question 4. Okay. For question 4, you need to write a program to evaluate the statement source code, directly match the left-right parentheses, brackets, and braces. So these 3 pair of things. And then if the parentheses, bracket and brace have we call it as a escape character. If have it in front, then we will escape it. We will not check it. So and then if the expression is missing, you will need to print it at the back. And then for if the balance expression is balanced, then you need to print it out. The expression is balanced, and then you need to show you need to print the directly below the expression that have problem. So here it will use put it here. This one is extra one, so below it, it will print it as an extra. And then for this one, because they are not, this one is, here it will have missing one bracket. Okay, so same, I'm using back the same stack class. And then I'm using my main method to this main class to check the whether the expression is balanced or not. Okay. So the main method only try to ask the user to script, then you will the program will stop, and then for every expression you will pass into the check expression method. So first of all, we need to start create a empty stack with empty character stack, because we only store the character inside the stack. And then we will have this field variable. The escape is check whether these parentheses have the escape character in front of it. And then the balance is whether the expression is valid, is true, balanced or not. If it's balanced, then we will print out the expression is balanced. If it's not, we will need to print out the position where it have missing or extra thing. Okay, this extra variable is to check whether it's extra or missing. If it's true, then it means that it has extra thing, so it should print out extra message, or it's missing, it will print out the missing message. Okay. So same as last question, I initialize the index outside of the so that I can use this index to print this, print the space before my error message, so that the index can be, so that the message can be directly pointing to the point where it have error. Check the current. If the current is the escape character, escape is equal to true, and we will not checking we will skip the step below. Do note that for this one, the character need to escape, because if you did not escape, it will try to escape the quote, single quote after it. So you need to put another one in front of it. So if escape is no, which means that and then is the start you need to and if check whether is empty. If it's empty, that you need to respond. For this is also the which then you need to check the previous one is corresponding bracket or not. For this one, the brace. So this one is the end braces, and this one is the start brace. And then I will set the balance to whether is same or not. If it's same, the balance will be true, and then if it's not same, then the balance will be false. And then for the other two type of the bracket, the parentheses and bracket, if is same, if the stack is empty, then extra, the extra brackets of parentheses, and then the is not balanced. So if is balanced, then you can pop it up from the stack. And if it's not balanced, you need to break this for loop. You do not need to check. And then after every character you check, you need to reset the escape to false again. So that it actually does not have something like, let's say this one. Actually, the escape is not in front of this one, but if you will not reset it to it as the escape character. Okay. Okay. So okay, for this one, actually I implement it a bit differently, which might not. Okay. So if the stack is not empty, let's say let's say the input is two start braces, then it will put it out in the end. So it will be like this. But it only show one time. For this question, it actually only show one time of the error message. You can try to you can try to implement the for my program. I did not print the message multiple times. I only print the one. Last one if found. If it's balanced, then you print the expression is balanced. If it's not balanced, you print the line and then you print the space before the error message, and then you check whether it's extra or missing. If extra, you print it as and then refer back. This one I will refer back to the line, and then for this I will check whether what is inside the stack of this. And then I will print it out. So for this one, it will print missing M bracket. So that's it for this program. Is there any question you want to ask? If there is no question, I will pass back to Wai Xiong for question 5.
Okay, for question 5, right, we're looking at XML document. So basically for XML document is quite similar with the HTML, where you have the element tag open and close, then inside you will put a value. So normally when you want to check whether the XML is valid or not, right? So basically we can using stack. It is because of stack we are using last in first out basis, right? So it is quite suitable for checking the XML element. So like for example, I have an element A open bracket, and then I have a B, then I have a C. So when I close have a close tag element, right? So for this one, I will check with the last element, last open element, which is C, see whether it is matched or not. Okay, then we found that it is not matched. Okay, so we can say that this one is not a valid document. Okay, so basically how it works is you will read the string. You read a string and you're trying to find the open tag, which is this one. So after the open tag, the value inside any value that inside here before this tag will be the name of the tag. Example for this one. The name will be test. And if you found that let's say if you read this one open tag, the open bracket, then read all the string until you found a close bracket. In this case, probably you found that the first character it is a string. So this means this one is a close. So you can indicate by the first character. This one, the first character is not this one. So this one is a open tag. This one, the first character is this one. So this one is a close tag. Okay, let's continue inside the program to see a clear picture. So here I have a input for the SML string, where I will check for this one it is valid or not. So I have built a method called check SML to check whether this string it is following the XML format. So this one probably the way I done is not quite efficient. So if you have the algorithm which is more efficient, probably you can share it to your others coursemate as well. So probably I have a boolean to check whether have I found tag inside. So I will read the character one by one. So if I found any escape character, I will just continue by skip the escape character. If I will check, so here we have two conditions. Either we found a tag or we didn't found a tag. So if we didn't found a tag, so we will check the character. It is a open bracket. If it is an open bracket, so that means we found a tag. So the next character when we start to read, it is a name for the tag hook. So if we've already found a tag, right? We are inside a tag. So we are looking for a close bracket. So the close bracket is indicate that we already reached the end of a tag. So if we found the close bracket, we will check whether we'll put the found tag equal to false. So this means the next character is not a tag and not one of the character of the name of the tag anymore. So after that, we will check before we found the close bracket. So after we found a tag, right? So that means after we found the open bracket, every character that we read, we will enter it inside a string that I called it tag to record the name of a string. So after I add until I reach a value which is a close bracket, so that means we already reached the end of a bracket. So in here we'll okay, first I check for the tag. If the tag is the length is equal to 0, so that means it has not a valid name. So that means probably the tag will be like this. Will be like this. So if we found that the tag after we check the length, and then we need to check for whether the tag is a open element or is the close open tag element or it is a closed tag element. So for the closed tag element, you will found a stress character after an open bracket. So if you indicate that the name that you read is like this, the first character is a stress. So this means this is a closed tag element. So we will pop element from the stack that we save, and we check whether it is valid or not. Well, if we didn't found this one, so it is a new open tag. So we will push it. So we will just push the, before we push, we will check whether the tag already exists. Since the question say we don't have duplicate element, duplicate tag element. So we will check whether it is consists already. If it is already consists, so we will return duplicate element found. Else we will push it inside a stack. So if we found the first character is trash, right? So we will pop it out. So before we pop it out, we were doing substring operation to remove the stress, so that the tag name we can get the correct tag name. So we will check the stack. If a stack is already don't have value, in this use case, probably you will face something like this. So this E close element, we want to find inside a stack. The stack already empty. So in this case, so you can you return that there's no begin element, so it's invalid ending element. Now if you found, else you pick the value from a stack, and if you found that it is not equal, right? So it is not equal, so probably it's like this. This one is a value inside stack with C. And now you want to check is a E1. So the C and the E is not matched to each other. So the begin element, which is C, which is invalid, have an invalid ending element E. If you pass through this task, so it means it is equal. So you just pop it. So you can see the example here. Okay, here I make some. I'm not sure for this one, is it counted as mistake or not? Because I'm not sure the question. Because the question didn't say that is this one counted as duplicate or not? Based on the algorithm, I have wrote for this one, it didn't detect as a duplicate. So let's do it. Okay, let's do another example. Before, in this case, we will find a duplicate element for the hash. Since the hash is already exists here, and then we do a hash again, element hash again here. So this one you will find is duplicate. So for this one, my element, my algorithm didn't found it as a duplicate because I only doing the checking which is in content the stack. Since here when it's pushed inside a stack and it pop from a stack, so the data element is not inside a stack anymore. So for here, when I do a checking again, it is not a duplicate. And then for this one, because the A, we don't have an open A. So you have found a invalid ending element A also. We here for this case. So in our stack we will have H A S, and we will pop a test, and then we have data. We pop the data, we push the data again, we pop the data again, and here we need to pop the hash, but here inside the stack is A, so it is not valid. Right, for this one is a valid SNL. So what you can improve for this method, right? Probably you can have a checking for the value between the open tag and the closed tag. So I put an example, right? So this one, after I put a open tag, before I put another element, I have some string value. So this one probably maybe is a invalid value. So maybe you can do some kind of checking that after the inside the tag, before you open another tag, you don't have any existing value. Okay, that's all for question 5. Any question for question 5? No question, that I will pass the next question to Jia Xiong for to conduct it.
Okay, so let's go to the last question. Sharing a screen. Okay. So let's look at the question first. So this question it asks us to solve the maze, right? So we don't have to look at the questions already. Look at the example output, right? The original maze is with S and as well as F. S is a starting point. F is our final point, in which we need to go and find the path to eventually reach this final point. So my assumption to this question is that the maze is solvable. So I have two assumptions here. The first assumption is that I have walls all around the maze. So there's no situation where my wall suddenly break or these things become spaces. Yeah. So I assume that all these walls are surrounding all of my points, starting point and final points. Right. The second assumption is that the final is always reachable. Right. So it is always able to go from the starting point and traverse until the final point. So these are my two assumptions. Definitely it can be another way around, but yeah. I'm lazy. Right. So how do we solve this question with stack? So first of all, we will have a position in which the position indicates the direction, x as well as the y coordinates. So when solving this kind of map questions, very important things that you need to be concerned is your definition of x and y and I and j. Yeah. Let's look at the concept first, right? Again, open the pen. And yeah, when you are, let's say when you are playing a games, right? No matter what kind of games, let's say a dungeon games that needs you to explore the area of unknown zones, right? Then these are the walls. These are walls. Then this is the, let's say the exit that you want to go to. And this is you, right? If you don't have any other information rather than yourself and your current position, then how do you want to find a way to the ending point, right? So, shit. Okay, these are walls, right? Then the more the cleanest and the most possible way of doing it is brute force. Okay, what do I mean by brute force is to explore every single point possible, right? So let's say this is you, right? Then the only information you get is everything surrounding you, left, top, right, and bottom, right? So let's say if you start exploring from the right, then you hit a wall. It means right is not your solution already. Then you try to go to bottom. Then bottom you can go there. So you try to go there first. Then go down again, go down again. Then go. When you go down here, every time when you go to a new zone, you'll try to explore the right first, then the bottom, then left, then top. Okay, so you go to the right, okay, cannot. You go to bottom, you go to right, cannot. You go to bottom. Then here you are. Go to the right side. Then you go to the right. Then right you cannot go. Bottom you cannot go. Left you cannot go because you have just gone there. Then you go to the top. Right now you go to the top and go again, then go again. Now you are here. And when you go to the right, you will achieve, you will solve all the maze. So this is a case where you only have one path, so it's easy, right? You can just attempt to go further down until you reach your ending point. But now the situation is that we are solving a maze, right? So a maze will look like this. One. Okay. Right. So let's say if you're going down here, then when you reach this point, you have two possibilities now. You can either go to a right or you can go to a down. So you need to make a mark first, right? Because you are solving a dungeon. Then after you go to a right and you go to the end, you go to a dead end already. Every possibility at the right is not a solution. Then now you go back to your original position. Then you don't want to traverse, you don't want to search this area already. The right side is already confirmed that the final point is not there. Your ending is not there. So you need to mark that as, okay, you cannot go there by any mechanism. Yeah, don't think about the codes first. Then you go down, right? After you go down, if you cannot find the solution again, then what should you do? Okay, left side already gone, top already gone, right already gone, then bottom already gone. Everywhere is not a solution for you. Then in that case, it means your final point is not there. Yeah. So supposedly when you traverse, by traverse I mean move to every point, every single point possible, you should be able to find the final point, right? If you cannot, then it's a game problem, not your problem, right? So we will see how it is achieved, right? So first of all, I get the inputs of this map. Yeah, basically it's the same map. Then try to print the original maze by doing the for each loop. So here I do another another loop, another two loops to find my starting point and ending point. Yeah. Then after this is the only starting point of my course. Yeah, I put everything in main so it looks a little bit lengthy. But anyway, we go back to the concept, right? Now we have a class position. Why is the position needs something like integer direction? Why is it needed? Right. So as I've mentioned, okay, I'm not able to undo already. Right. So as I've mentioned, this is you. The only thing you know is your current position. So now, if we only have mechanism to find if this place is visited, it is actually not enough for us, right? Even if this is visited, it's possible that this position is not part of the path for me to reach my destination. Why? Because let's say if you go to the right side, right? You go to the right side, then you find the right side is not a solution. Then here you go to every single possible solution already. So now the bottom is not a solution again, top is not a solution again. So now what you have to do is you need to go back to a previous point and find the other place that you haven't gone, right? So this is a backtracking or undo mechanism. You need to ensure that your program is able to undo your current position to your previous state. So this is a state, right? So we need another logic to handle the state of my current position. So what I mean by state is that, okay, this position, right, you already go to right. Never mind, we start from the previous one. Okay. It might be a little bit overwhelming, but you can try to get the concept. Right. So now the current direction is right for your previous point, right? So this is right. Then after you have tried every possibilities here, you found that, okay, here you need to go back already. Then your current state will be moving from right to bottom. Right. So you can see all your current position, it has to handle four direction: top, right, bottom, left. Then if these four positions already tried, then you go back to the previous one. Then the previous one, you already have the state of going to down. So it won't go to right again. If you don't have this state, right? If you don't have this state, the possible outcome is that it will keep trying to the right side. Okay, because you didn't store the state. Then you finish explore the right direction. You don't find a solution. You go back here. Then you go to right again. It will become a dead loop. Yeah, infinite loop. Then there's a reason why we need to have a state. So how I define this state is I use an integer because the state is either left, right, or top or bottom. Right, so it's a for state. Now let's look at what this state does. So first of all, I have a visited 2D array. So this 2D array is corresponding to the map. It's same as a map, but it's to indicate whether the place is visited or not. So by what I mean of visited, it's not necessarily that I have gone to this, I have explored this area, then this is visited. Yeah. At the end, after I finish computing, right, the only visited area is the path to my final destination. And this is the thing I want. I don't want every single point I have visited. So after let's say I visited here, right? I don't want it to be included in my final path because it's not a solution. So I need to erase the visited. Later, if it's not clear again, I'll try to explain the concept again, right? So at first, you initialize your starting point and set the visitor to true. This might not be needed actually, but yeah. Anyway, then you have a stack of positions. Push a position to the position stack because you want to keep track of the latest position, okay? Then while the position is not empty, it means while you have not finished traversing entire map, you'll get the current position, you'll get the previous direction. It means currently the direction is 0, right? So 0, you try to increment by 1, then you push back to the position again. So now here is your starting point. It initially is 0, indicating to the up. Let's say 0 is up. So you will increment it, become direction right. Then you store it back to the stack in case you might need it in the future. Right, so you push back into the positions. Then if you hit the jackpot, it's the final destination, then you will break the loop. Or if it is 0, then you try to go to upside. And here you can see I'm checking the map if it is a wall, and I'm checking if it is already visited. Yeah, so if not yet visited and the map is not a wall, then I will try to push it, say to visited, and I try to traverse to that position. This is for up. As you can see, I didn't check for the edge. So for example, if because of my assumption that it is surrounded by wall. So there's no cases where my S is at the edge. Then I try to get the left side, and I get the index of bound exception. Yeah, I don't have to worry about it because there's a wall, right? Then 1 is to the right side, yeah, and down is to the 2 is to the down, then 3 is to the left. All are the same things. The only things that you need to be concerned about is your definition of x and y. Okay, I've mentioned that so when you are looping the array, right, for I integer I equals 0 until length, for integer no, this is your I, right? You're going down, then this is your j, integer j inside your array. So when you are looping, the I is going down. Yeah, I equals to 0, I equals to 1, I equals to 2. I is your row. Then j is your column. Yeah, j equals to 0, 1, 2. But when I'm defining my x, I actually indicate that the x is going to the right. Okay, so x is equals to column. Yeah. So by my mean, x is equals to I. Okay, x is equal to I. Then y equals to j. And yeah, that's it. J. No. Yeah, that's why I always confused about this. Okay, so x is equal to j because I'm going to the right side. Then y is going down, so it is I equals to a raw number. Then if you have this concept in your mind, then you can try. If you are pointing to the right direction. Yeah, my y is at the I, my x is at the j. Y is I, x is j. Yeah, so it's correct. So you try to go to 4 directions and try to push it whenever you can, push to the stack of positions. Then if you have no more path to go, you are setting the visitor to false. So this is the mechanism which I remove the points that I confirm already is not the path to the destination. And I pop the position stack in order to go to undo to my previous stack. So in this case, the position stack is actually something like a undo feature. Yeah, an undo feature for you. So undo means you want to go back to your latest state, right? So stack, it can solve your problem of going to the latest state. Then after I compute, I get out of this loop, I will go to the I go to print the result, and the result maze is something like this. Yeah, we'll try run once, then go back to a concept again. Yeah, because of time constraint, then might not be able to show you the codes like very detailed. So the original maze is like this. Then I get a result maze. The only path that get me to the final position. All right. Now, go back to a picture again. Okay. let's say okay, something like this only. This is wall, this is wall. So I need a branch to, let's say I'm here, then I want to go to the them. Should put myself here. Never mind. Okay, so like this, right? Let's say if you have branch from going down, you can go down. Then this is your final destination, right? Now, the mechanism is I go to a right, then I go to right, top, left, down. Okay, right, top, left, down. So first, right is fail. So I increase the direction, become 1. Right. Then I go down here. Remember, 1 is indicating the direction, current direction. Okay. Right. Bottom. Never mind like this. Right, bottom, left, top. Okay. So now one right is already explore, so it become 2. So it's starting from the array index start from 1. Okay. Then now here you are reaching the second position. Then second position, your also you attempt to the right side, right? So it also become 2 already. The next time when you arrive at this particular block, you will be exploring from bottom or from top, right? So now, okay, sorry, my bad. At first you go to right, okay, 1 become 2. Then you go to a down, then 2 become 3 already because down you already explore. Then this also the same. At first you go to right, okay, right become down. Then down you go again. Now you're here, and here is pointing to 3. So it means next time you go here, you get a 3, then you must go to the left already. You cannot go back to right or bottom because you already explore it, right? So now it's 1, then it become 2 because you go to the right side. So as you can see, your final point is here already, but you didn't go straight to the bottom because you want to traverse all around your right, bottom, left, top. So this is a brute force way of doing things. So you go to the right again, right? This is 2. I hope you understand the meaning of the number here. It's indicating your position. Yeah. So now you're reaching the end of right, then you go to a down. If you want to go to down, here is 3. So you are here. Oh, here I go to the right, bottom, left, and top. Oh, I get a 5 already because I go back to top. Then there's nothing left here. So this I need to undo back to the previous state. And I will try to increment this 3 to 4, right? Because I haven't tried up yet. So no, when I increment the 3 to 4, I will try the left side first. Then the left side is already visited. So I will traverse again. This becomes 5. I'll go back to up. Then here's the same thing, right, left, down, and the same thing. Until the end, I reach a 5. Then I pop. I reach a 5, then pop. Then here, because I reach a 5, right? So it is the same consequences than the other position. I will pop it out of my stack and go back to a previous state. So the current state is 2. It will become 3 and try to go down. It will become 4 to try to go left. It will become 5 to try to go up. Then it reach a 5. It will pop itself again. So currently I reach this position. This 2 will become 3. Then it will go down and I get my final point. Yeah, that's the concept. I'm not sure if you can get it. How to say? Okay, so you can see this number, right? These numbers, what it helps is that it stores the direction information to the current block. So it means that even if, let's say, if you have visited all the right things, right? They are not the solution. As I've mentioned, the visited will be false. At first, it will be true, yes, because we have visited that block. But when we are undo, we actually remove the visited. So the visited flag, there's a flag here. Yeah, the flag here called visited. This flag is removed from here. So it means all these paths that are not possible to be my answer will be removed from the visited array. It will become a false. So I cannot identify that I have visited toast zone because the visit is already false. So the way I'm doing this is because of this direction is not reversible. It means after the 1 has become 2, right, it's not possible for me to go to the 1 already. Or in English, right, if the right has become down, I cannot go back to right side already. Yeah, it's only incrementing. The direction will never become like 4 become 1. It's not possible. So that's why I don't need a flag. I don't need this visited flag already. If I finish visit my right side, right? Because I increase the count by 1, then I will never be able to go to the right side. Same goes to other things. When I'm traversing, finish this 2, it becomes 3. It's not possible to go to 2 and 1 already. So it might sound okay. Okay. So I can say that this is not very straightforward. Yeah, this implementation of stack is pretty hard actually. So if you can try yourself, if you cannot really cannot code until this, maybe you can try to refer to your online solution first and try to think why they are implementing that way. So, but in my opinion, stack is the questions here at least they are not very easy. They're pretty hard. And what I can say is that in normal use case, okay, I'm saying if possible, yeah, try to make your program as easy to understand as possible. Yeah. So in the actual project or something like that, we won't try to use some complicated algorithm or data structure. Things should be as easy as possible. Uh, these kind of things are important for your. You can train your logical thinking. You can train, yeah, basically logical thinking. Yeah. So it requires some practices. It is not easy, and things will get harder and harder. So yeah, that's it. That's it for question six. Any problems? If you need more explanations on the state management, I can say it's state management. Yeah. Then you can ask me. Then we can further discuss about it. Yeah. So that's it for lab 5. It's just nice 12 p.m. So if you don't have any problems, I'll pass back to doctor. Right.
Okay. I got one thing to add on about this. For question 6, yeah, last year final exam is something similar to this. You, I not sure it's questions 4 or question 3. They score 4 questions, and one of the question is like this. You need to use the stack to find the path, and then you print out the path. Okay, that's it from me. I will pass back to doctor.
Okay, thank you, Sia, and other demos. Good explanation you had. Thank you so much. Uh, do you have any questions? Is there any question? Okay, I want to say something about DS assignment. I already updated the Padlet yesterday. So you can go to Padlet or day before yesterday, I think. You can go to Padlet and see your group mates. Then you need to determine uh, what is the plan for doing the assignment, and you need to share the work between the members of your team. For example, you should divide the workload between the members. Member yeah, member one should do these things. Member two is going to do these things. Member three is going to do these things, and you need to write down on your column, your group column in Padlet, what is the duty of each member. Okay, every activity that you have regarding the assignment, uh, you need to write in Padlet. I don't mean that you write your code or some confidential thing in Padlet. Just I need to know your progress. So, for example, if you have planning for doing your project, if you are going to divide the work between your members, if you already done some steps of your work, your assignment, you just write comment under the column in Padlet. Any question? I already wrote the instruction in Padlet. So if you refer to that, you can see the instruction and what I need you to do. Do you have any question? Okay, thank you to Demos for their nice explanation. Very good, and you are lucky that you have these demos. You are lucky that you are in group 5 and your demos are these teams. This team. Okay, have a nice weekend, and if you don't have question, uh, you can leave the class.